let's do another fun activity, and this time let's model the different states of water, what we call as phases of water. Okay, so let's create a package. Let's name it as water phases, right? And let's create a class and let's name it as water. Okay, and for this let's add a diagram, a state machine diagram. Okay, now let's identify the different states. We know water exists in solid, liquid, and vapor states. Okay, so let's now figure out from which state to which state it can go. So it can go from solid to liquid, right? And it can go from liquid back to solid. Okay, then it can go from liquid to vapor, and it can go from vapor to liquid, and it can go from solid to vapor and vapors to solid. Okay, now what we'll also do is what happens as part of this transition. So what is happening here? Liquid to solid melting, okay, and liquid to solid is freezing. Similarly, vapor to liquid is condensation. And liquid to vapor is vaporization. Now, vapor to solid is deposition, and from solid to vapor is sublimation, right? So while it is shifting from liquid to vapor, we say it is vaporizing. So vaporization process is happening as part of this transition. Similarly, condensation is happening as part of this transition. Okay, now next is to figure out what are the conditions that has to be satisfied. Now the conditions are temperature is greater than melting point at the current pressure, and the temperature pressure combination is greater than the triple point. Okay, let's format it. Yes. Now what about the other way around? Freezing. Now here the condition is temperature is less than freezing point, and this is at a particular pressure, because depending on the pressure the freezing point, melting point, they will differ. Okay, and the temperature pressure combination is greater than the triple point. Again, let's format it. We can make more space for this. Now what about condensation? Now here again temperature is less than boiling point at a pressure, and temperature pressure combination is less than, no, is greater than triple point. Okay, so this is condensation, this one. Okay, what about vaporization? Here again, temperature is greater than boiling point at a particular pressure. And the temperature pressure combination is greater than triple point. Now, what about deposition? In case of deposition, the guard conditions are temperature pressure is less than triple point, and temperature is less than sublimation temperature at a particular pressure. Okay, again we can keep making space for this. Okay, let's, okay, now sublimation. Here the temperature pressure is less than the triple point, and the temperature is what was the other one that we had put? Temperature is less than, so here temperature is greater than, what we can do is copy paste this itself. Is less than sublimation temperature at a given pressure. Okay, now if you notice here, there is no equal to triple point. Yes, so which means that when it is at triple point, it can exist in all these states. Remember, we have not actually given any triggers for this. What will be the triggers? We have given the what happens during the transition, freezing, melting, deposition and all that. We have also given the guard conditions, but we have not specified what triggers these transitions. So for that, uh, at every stage, I will have to show change in temperature, change in pressure, change in temperature, change in pressure, change in temperature, change in pressure. Now, instead of doing that repetitively, what I can do is I can define a stage, and for want of a better this one, let's name it as water state, and let's make this include everything, and Z order send to bottom, and just move it a little bit so that it actually gets embedded into this stage. Now here this is called the super state, and these are called the substates. So anything that you want to specify with respect to all the three states, substates, you can specify it at the super state level itself. So now what I can do is I can show a transition. I can show a transition and specify the trigger. Change pressure is the event. Similarly, change temperature. Now, with respect to this itself, I don't show anything. So these two triggers are there. These two transitions are there just to show the triggers. Based on these triggers, all these things internally happens. As the guard conditions are satisfied, the state transitions occur or phase changes occur. Okay. So as you noticed, don't get bogged down with the water part of it. Focus on the state machine diagram and how it helps us in making sure purpose of modeling. Make sure we understand what needs to be understood. And second is convey our understanding to others. Yes. Okay. While editing, I noticed one mistake that I had made. Remember, I copied the add condition from here to here, but while making the necessary change, I removed the wrong symbol. So temperature should be greater than that sublimation temperature for it to go from solid state to vapor state. Okay, so that is one of the problems with copy paste. The chance of making mistake is much higher. Okay, anyhow, that's it for now. Bye. See you next time.